Welcome to the fourth part of the lectures on the research group Earth System Data Exploration at the Jülich Supercomputing Centre. This time we are going to explore the data infrastructure we are building primarily in support of the TOAR assessment activity. We exploit modern IT concepts to build user-friendly, functional, high-performance environmental data services. So I mentioned earlier already that relevant research needs good data, and how to get to good data is a big question. And in particular, it means that you have to get good access to these kind of data. And I think in particular with the TOAR database, we are building this kind of infrastructure and also testing new concepts, how one can make, in particular, very diverse data sets easily available to the research community to do all kinds of exciting things, and of course including ourselves as being part of this research community. So let me go a bit into detail about this. So the TOAR database has been the foundation of the first tropospheric ozone assessment. It's really a unique collection of global long-term surface ozone observations, which now covers more than 13,000 sites from about 15 different networks and many individual contributions. There's a paper describing the database in the special issue of TOAR in the Elementa journal. We have about 350 users and more than 30 ozone metrics directly accessible from the database. And I think one of the unique selling points of our database compared to many other data services that you can find, or actually pretty much all other data services that you can find in this area, is that we basically allow online computing of these ozone metrics directly from the data in the database. What we are now building for the second phase of TOAR, so the TOAR 2 assessment, is the TOAR Data Center, which is much more than a database, and it's summarized here in this view graph. So the TOAR Data Center is basically a part of our team building and operating these data services. And these services consist of 4 elements. We have the TOAR database in the center there, which is also combined with a graphical user interface, the join web interface. A new element of the TOAR database are now the TOAR data publications, which allow people who send us their data to actually get a DOI, so a digital object identifier for this, and which of course increases the attraction of sending data to us, so they actually have a publication associated with it. And a new element that we are also building is the TOAR data portal with the domain toardata.org. Which is really sort of a one-stop access, one-stop shop portal for ozone data. And yeah, the 2 really new elements here are the TOAR data portal and the TOAR data publications. But of course, there's also many developments in the database to which I will come back to later. Now, just a few snapshots of the TOAR data portal. So the main mission of this TOAR data portal is to make it easy to find ozone data sets around the world. And they're grouped here in different categories: satellite data, surface data, ozone sonde and LiDAR data, and aircraft data. Potentially, at some point, we may also add model data here. We don't know yet. And we're basically expanding this portal to also provide data center news. So things like when we are involved in certain activities, like the upcoming WMO data conference, or Amir Pasha has presented at the Research Data Alliance. So these kind of news will be shared, but also once we're beginning the big data collection phase of the next TOAR, which will likely start sometime mid next year. Then when we basically made major upgrades to the data in the database, or received contributions from new countries, or these kind of things are definitely newsworthy for the TOAR data portal. Since we want to basically make it easy to find these data sets, but we also want to make it easy to for others to access these kind of data sets. And so therefore we designed these kind of boxes here to describe individual data sets. So here's a snapshot from the ozone sonde and LiDAR data, where basically you can find in these boxes different links. So there's first the title of the data set, which will lead you as directly as possible to the actual data. So often this will be another data catalog from where you then have to select your specific data set and then somehow try to find out how to download it. But sometimes it could also lead to some other web page or so, basically giving you access to the data. Then there is a descriptive text with a link to the homepage of the data set. This could be the same as the first link, but very often it's not. So in many of these links, you see descriptions of these data sets stored at other URLs, basically, than the access point to the data. And then at the bottom, you see these three elements there, and they basically point to either a REST interface, a machine-to-machine interface, which would give you direct access to the data through programs, if it's available. So unfortunately, not too many of these data centers do provide these REST APIs. Then the second is a contact link. So in some of these data center pages, you will find indeed a contact information or a contact form or something like this. And then we will link to it here. And the third element that's also crucial with respect to fair and open data sharing is to make the licensing conditions of the data easily known. And so that's why we include basically a link to the data use policy or license also in this bottom box here. And so these elements are meant to make it as easy as possible for people to not only identify these data sets, but also then find out basically how useful they are for their kind of work and studies, and get access to these data. The second thing, which basically provides a window to the world from what we're doing here, is the graphical user interface join. So here's a snapshot of the soon-to-be operational leaflet version of this, where basically you see clusters of stations, and then you can click on these clusters and you will get a magnification, a zoom of the map until you finally see the individual sites. And then for each of these sites, you will get descriptions like metadata, extensive metadata descriptions, but also links then to the individual time series that are stored for the station. And then once you click on one of these time series links, so for example, ozone, you will get these data extraction options that allow you to get all kinds of aggregates, either as plots or data sets, all kinds of different metrics, either standard statistics or specific ozone metrics. We are also working quite a bit on improving the database itself. So this led to an improved database structure already. So the database schema has been completely revised from TOAR 1 to now. And associated with this is also an improved workflow for the data ingestion and metadata. This is now depicted here, where basically data providers send us their data. I mean, in fact, we have different workflows because a lot of the data that we get for the TOAR database comes from other managed data centers, where we more or less just download a copy of that data and then insert it into our database. But then, as I mentioned earlier, we have actually about 50 or so individual data providers who send us their data files directly. And so for those, this workflow here applies, where we get this initial submission from the data provider as data files. First, a pre-screening will happen. That's a manual step. So specifically, Sabine will look at the data and find out if it's at all suitable for inclusion in the TOAR database. Then the raw data will be stored and archived for later use if it needs to be reproduced at some point. And then a big step happens in terms of harmonizing the metadata and the data format. I think I'm saying this quite frequently, but you just don't believe how many different ways of adhering to a standard data format can happen. And so very often there are even minor corrections necessary. For example, in the way the date format is specified, or certain metadata elements, how they're written and stuff like that. And one new aspect here is now that we're beginning to make use of controlled vocabulary for the metadata descriptions in order to limit basically the terms that are available, and therefore make data better comparable and easier to compare. Once we have a harmonized data format, the data is then ingested into a staging database. So this is a temporary database that's also then linked to the or a copy of the joint web service. I guess the details here still need to be defined. And that can be made available then to the data providers for feedback. But before we do that, there is a data quality check run with an automated tool developed by Najme, so the AutoQA for ENV. And the results of this as a data quality report, together with other information, will be then sent by email to the data provider to basically ask them to approve of the way we handle their data and basically release the data for inclusion in the database. So the data provider can decide whether the data is okay. If yes, they will be moved to the TOAR database. If not, either we can do some corrections, or it will lead to a resubmission of the data, and then of course the workflow needs to be run through again. Once the data are in the TOAR database, the processing log will be stored and also made available to users, and the data will be released. And the end product is basically then the web access to the data and metadata, either through the graphical user interface join or through a REST API. The second point, which is also new now, that the data provider can decide, is whether they do want a data DOI for their data, so a data publication. If yes, we create a B2Share record. If no, nothing follows and they can go and have coffee. Well, they can have it anyway, but we can also have coffee. And if we create the B2Share record, then as part of this, a DOI, a digital object identifier, will be assigned, and we basically then have this optional data publication with the DOI that we can make available to the community. One part of this TOAR database infrastructure, which is also very important, and we are just now in the process of finally realizing this through a web service architecture, is the enhancement of the station metadata through geospatial data. And here's just one snapshot from OpenStreetMap, where you can basically identify the distance to the next major road. I'm just seeing that this has been a bit distorted, the picture, from trying to fit it into the presentation here, but never mind. So basically what you can do is you can issue a query to this web service here called Major Roads. You can issue the coordinates of your station. You can specify a radius in which you want to retrieve that information, and also say whether you want this listed in individual wind sectors or just as a total nearest distance. And then you will get back a JSON structure basically with all kinds of information in terms of the distance and the compassed angle for the individual wind sectors, and then even things like the road name can be returned back from OpenStreetMap. And there are other services that Lukas has already developed for looking at, for example, population density or topography information, which can then be augment the metadata in the TOAR database. And this, of course, is a key element also for the mapping team, basically, in the machine learning applications. So just to summarize here how we do the processing of this geospatial data. So there's different data sources, of course. So one branch here is the OpenStreetMap servers. We run instances of all three elements here. So the nominatim server is the one that's crucial for this geolocation service. But there are others like the tile servers, which we can also then exploit in our web applications. And even forgot the third one right now, but never mind. So basically, this needs to be updated. It's actually amazing when I looked into this about a year ago or so, how many updates are made to OpenStreetMaps every day. And so it's clearly important if we operate this as an instance here that we also keep up to date and manage sort of this instance of the OpenStreetMap server. So Jianing is in charge of that now. And then the OpenStreetMap servers, of course, come with their own URLs basically to make queries, which is then used in the TOAR location service. The second branch consists all kinds of data sources, which are now retrieved by Amir Pasha. So those are mostly data files. Sometimes the data comes in individual tiles. They are all being integrated into consistent data sets on the so-called Rasterman GeoCube, which again comes with its own application interface. So either as a REST API or also a graphical web interface. Again, this REST URI is queried from the TOAR location service. And then the output of that can be used either in the TOAR database or in the machine learning applications. And of course, we can exploit both the GeoCube directly or the TOAR location service in the machine learning applications, depending on what type of data we need. And this then is part of the overall data and service architecture that we're building here. So basically, I'm trying now to highlight this with respect to the different projects, where the focus lies of these different projects. So again, we see here the first branch on top is basically for the meteorological model data, where we're really caring a lot about workflow and performance issues, where we're setting up the Rasterman systems to build the MeteoCube, and then look into applying these kind of data for machine learning applications. The second stream is really the geospatial data, which ends up in the GeoCube, then to provide services. And the third stream of data are the time series from all kinds of sources, which end up in the TOAR database, and again are feeding into science, basically, products and services. And so for TOAR2 and IntelliAQ, the focus is really on the bottom part of this. So primarily really focusing on the time series and the geodata. Of course, we also make use of meteorological data here. But let's say from the project perspective, the focus is not so much on developing new solutions, but rather just using the data as they are. In contrast, in Deep Rain, the focus is more on the upper part here, where really it's a big focus on the project, in particular of our Jülich activities, is to analyze this performance and improve the workflow for the big model data and make use of this Rasterman technology basically in the MeteoCube. And also then explore how one can directly access databases in machine learning applications. And of course, we also need the geospatial information, in particular topography, for the rainfall predictions in Deep Rain. In KISTE, the focus is more on the data uptake side, so to speak. So not so much making new data available, but rather exploring the use of these data and building then these kind of AI platforms. So basically how to streamline and also standardize the process of making use of that data, building benchmark data sets and these kind of things, so that other people in the community can make use of the data that we are generating or that we're managing. And finally, in Maelstrom, the focus is again on the top part, really performance, directed to performance of weather data analysis, and of course also building the applications on the weather data. And here maybe the focus is a bit more on computing aspects rather than the workflow aspects. Okay, so that summarizes the data infrastructures, and here's just a snapshot of the timeline for the TOAR data infrastructure. So the TOAR2 initiative aims to publish basically their next set of assessment papers in 2024. And in order to make this happen, we have to adhere to a certain time schedule here. So the idea for 2020 is to design the data infrastructure and bring the data backend online. So basically have the new TOAR database running, including the links to the geospatial data. And next year, we are really then aiming for optimizing the performance of the system, designing the new web services for TOAR 2, so basically a relaunch of Join web interface. And as I said earlier, approximately middle next year, we're expecting then the first data submissions. And then 2022, if things go well, we should be really implementing improved web applications. So this could then also include new features, like for example, running the DOSE web service that Clara is building online. Of course, if it's ready earlier, we can also implement it earlier, but that would be sort of the target line for this. We would really then in 2022 probably receive a lot of data submissions and also need to update the data from the large networks. This will be a huge undertaking to get all that new data and updates from the existing data into the database, and then generate sample data products. Because one of the crucial aspects of the assessment itself will again be data summaries, basically. So as we did in the first assessment, we generated lots of large Excel spreadsheets and things that can then be analyzed by people in the community. And I guess this time we would like to automate that a bit more so that these kind of spreadsheets, for example, could be generated by users directly. And then 2023, we should generate the final products and publish also the TOAR data product so that they can be again taken up by and used in the TOAR assessment. So this video concludes the small lecture series on the Earth System Data Exploration Group at the Jülich Supercomputing Centre. For group members, there's an extra video available which talks a bit about management issues and the group organization. Thank you very much for watching this.